that is in your screen.
You might have did
I'll share a
like
screenshot of my screen.
okay. I'll try to see if there is. I will complete this and later we can discuss. Okay, so first I'll explain all the commands and process until image minimization. After that, no, we'll have discussion and I'll try to help you. Okay, is it okay?
Okay, sir. Okay, sir.
Okay.
Okay.
After this hyphen D uh, places the protein 1 nanometer from the uh, side of each dimension. Okay, so there is a gap between the wall and the protein, that is 1 nanometer. Okay. This is to solve it this box. Previously, we created these box around the protein. Now we are going to solve add water molecules around the protein. So inside the box, we are adding the water molecules. So for that, it takes this input file, and here we are giving the SPC 216.grow. It is the structure file of SPC water molecule. So we are taking that and placing inside the box. It added 18,464 water molecules in the box. So
Sir, why are we adding water, sir? What is the purpose?
it means simulation can we can do simulation in vacuum, but no protein molecules are biological molecules. So in the biological environment, it is in the water. So we want similar environment in the MD simulation. That's why we are adding water around the protein or water environment. Okay. Okay.
ഇങ്ങോട്ട് വരണ്ട. അവിടെ കോളായിക്കൊണ്ടിരിക്കുക. ആൾക്കാരെല്ലാം ആർക്കും മനസ്സിലാവുന്നില്ല ഒന്നും. എല്ലാവരും ഭയങ്കര പ്രശ്നം ഉണ്ടായിരുന്നു. ആർക്കൊന്നും മനസ്സിലാവുന്നില്ല. പൈക്ക് ആർക്കൊന്നും മനസ്സിലാവുന്നില്ല. അതും ബെൻസി വിളിച്ചു പറഞ്ഞു. ബെൻസി ഇപ്പം വിളിക്കുവാണ്. അന്നേ ഇങ്ങനെ ആയിരുന്നു. അവരത് വരുന്നവർക്കൊന്നും മനസ്സിലാവുന്നില്ല. അവൻ്റെ പുറകെ പോയി പിടിച്ചെടുക്കാൻ പറ്റുമോ? പുറകെ പോയി ശ്രദ്ധിച്ചിരുന്ന് പിടിച്ചെടുക്കണം. പോയിക്കോ. എന്താ സംഭവിക്കുന്നത്?
Yeah, means I'll uh, means in each and every step, the topology file updates the things what we are doing. Now we added solvent molecule. Okay, so the number of solvent molecule or what type of solvent molecule we added. So that is there in the file. Okay, so each and every step uh, steps information is added in the topology file. Okay. Now I'll show the solvent molecule. Okay, so it added solvents in the inside the box. Okay, so you can see it. The next step we have to add ions. Means the after adding water molecule, the charge of protein is changed and it influences in the environment. So we have to neutralize the simulation box. Okay, so it is necessary. Otherwise, the if if charge is not neutralized, it may create some problem in the molecular dynamics. Protein's nature will be different without neutralization or with neutralization. Okay, there is a difference. So we must neutralize it. For that, this command process try to calculate the charge of protein. Okay. Uh, the charge of the
Sir,
protein.
I think your voice got a little cut off in between. Why are we neutralizing the charges inside the box, sir? By adding ions, what charges are we neutralizing and why?
Actually, uh, protein uh, protein has charge around this. Each and every
Hello.
protein is having a particular charge, and we are adding water
No,
molecule
it's Dr. Naushad.
uh,
I am coordinating the call.
water molecule in the box. So whole system has to be neutralized. Okay, so if it is neutralized, it does not create any imbalance. Okay,
Yes, yes, yes.
during MD simulation, if you are not neutralizing, uh, it is in the
Fees
negative
structure.
charge. In this case, our protein is
Fee structure is 2000 rupees.
having
That will
minus
be
7
2000.
charge. Okay, so
2000.
we are simulating the negatively
So
charged
it takes
protein. If you are
100
neutralized,
So, to
rupees
my understanding,
rupees
I think
per
initially we'll remove the
to
charge of
7:30
protein
or
so that we can calculate the topology.
evening.
Later, we'll add the ions which we removed in the initial stage so that the protein will come back to its original nature.
no, no, it is
Before,
not
It's not like
correct.
it is not like,
Actually,
okay.
uh,
Uh,
and it will be on
normally protein has some charge. Okay, so in natural environment, or we are
you can
taking the
send
simulation box.
this number, you can
Uh,
send a hi
in each
one,
and
so I will
every
send the link, so you can
every
increase
environment,
by
protein
Google Pay or something, just upload
must have some
the receipt
charge.
in the
But
Google
no,
Form.
for MD simulation,
It will be
we should not uh, simulate the protein
no, no,
with
around
charges. Okay,
50.
so you know the effect of pH. pH affects the
Yes,
protein's
yes.
nature.
Last
If
number
it
is
is
7. I think it is. So my bad, sorry.
negative,
Yes, yes,
it
yes.
its dynamics different.
Next minute.
If it is
Yes,
positive, its dynamics or function
yes,
is different.
yes, yes, yes.
So in MD simulation, we have to neutralize it before simulation. So that we are doing in this step. Okay, is it okay or
So it's related to force field.
no? It's not related to force field. Uh, force field will calculate the charge of protein, but more than that, we have to add negative charge to the whole environment. The complete simulation box has to be neutralized, so that we are doing.
I'm sorry, sir. I'm still not clear. Can you please explain it once again or in detail, please?
Uh, why charge? Does charge affects protein?
Yes, it does.
Okay, means if it is positive, it interacts with different molecule, or sometimes it may aggregate in positive charge. Uh, in negative charge also, it may degrade or it cannot function properly. Okay, but
Yes, sir. My doubt is why we are initially removing all the charges, then we are adding.
no, we are not removing any charges and adding here. Previously, we calculated and we retained that information. We didn't do anything at the first step. Now we are adding it. Okay, so before adding the charge, we have to process or
Sir, if not removed, why we are adding now, sir? If we did not remove, why we are adding? Because the protein that we download is without charge or something like that.
no.
In
Initially, it may have charge. It did not have that. It did not add that information. Okay. Now we are processing that in uh, GROMACS, and that information is information is with us. And before adding, no, so we have to process it, process the calculation, and wait, uh, it takes an MDPS. Okay, so is no, actually after adding solvent, some charge. There may be some difference in the charge, so that is calculated here. So previously we processed only protein molecule. Now we added solvent. Sometimes solvent uh, environment may change protein's charge, but no, mostly it won't change. So that's what we calculated here. Okay.
okay, sir. What protein are we using for the
Yeah,
last
it took lipase molecule.
lipase?
Yeah,
Okay. Solvent, sir. Which solvent we are adding with lipase?
SPC. I told
Okay, SPC. Okay.
SPC.
Why are we adding SPC, sir? Because it will function only with SPC like this.
No, it is simple water model. There are many water models to include in the simulation log. Tip 3 is there, tip 4, even tip 5 is there. So these are all some water models. and there are many other, but it is very simple. I think 3 point model charge, I think. So we are using the simplest water one. Okay. Yeah. Now we processed it, and in the next step we have to add new so 7 sodium atoms. Okay, so in this step we are generating ions. Okay, that's it is going to happen here, and it takes this input file. Okay, and uh, we have a positive sodium ion and negative chlorine ion. So you may name how many ions must add, but no, it is simple to use uh, this one. If you add neutral or hyphen neutral, so uh, it automatically adds the needed charge in the box. Okay, so our protein is -7 in charge. Now it will add 7 sodium atoms in this step. So we are adding additional ions or additional atoms here. We already filled with water and protein. Uh, we, uh, we must replace something. Okay, so we have to replace with the water. So I'm giving 13 uh, 13 further. Okay, so it replaces solvent molecule or in the place of sodium atom, sodium ions. Okay, so it is. So here you can see it replaced.
Sir, these are the common steps for all the protein, or based on the protein nature, it means we need to change any command.
No, we have to do the same thing for each and every protein. It's
Okay.
now in topology side. Now we can see that. Okay, so 7 sodium atoms are ions are added. Okay. And these blue dots are sodium, so it added 7 sodium. So they are here. we neutralize the whole system, and now we are going to uh, minimize the energy. Okay, for that we are preparing the input file for energy minimization. Okay, so uh, MDP file is a parameter file or energy minimization parameter file. So what we are going to do in the energy minimization is given here. Okay. It is the title, and we are going to use this steepest descent method here. Okay. That is the integrator, and energy minimization will stop when it reaches 10 kilojoule per mole. Okay, so it is mentioned here, and energy minimization steps are 0.01 picosecond. So uh, that is here, and how many steps are how many steps it must run? It is here. It is here. It has to run 50,000 steps. Okay, and we are defining further things here. Is it is going to use Verlet algorithm. So we told that we know that it is using Newton's second equation, that is for F is equal to ma. So that's Newton equation is integrated and integrated in the Verlet algorithm to calculate its position, velocity, and other things. So that is uh, that is uh, that is mentioned here, and it takes grid. Okay, so it uses grid uh, search for calculating non-bounded interaction and other things. And Coulombic interaction is defined here. It is one. The parameter is one, and van der Waals cutoff is one. PBC, we know what is PBC. So PBC must include in all direction. Okay, so X, Y, Z. So these things are mentioned in the parameter energy minimization parameter file. So we are going to process this in this step. Okay. Okay, now it started running energy minimization. So it takes many steps to reach there. So all the informations are updating. It will stop once it reaches its calculation. Yeah, it's completed.
അതെന്താണ്ടൊക്കെ എടുത്തിട്ടാണ് ചീറ്റിപ്പോയി. എല്ലാവരും അവിടെ ഇരിപ്പുണ്ട്. പക്ഷേ I have all the files you sent.
In
How to bring it to
now energy minimization is completed. Okay, so
Dr. Bharati, a question is there in the chat box. Can you check it?
yes. Okay. Now I'm taking the energy file of energy minimization. From that, I calculated or I retried the potential information. So I want to visualize it.
ഈ കഥ നടത്തേര്
Mm. What happened was my initial confirmation was in this energy at starting, and we did the energy minimization process, okay, using steepest descent method. So it bring down the structure's energy to this. Okay, so from minus 5 e plus 0. From this to it reached this position. Okay, so almost the protein's energy changed from higher energy to lower energy. So that information is there in that. Okay, so in this, no, so the curve should be like this. Okay, uh, here it should reach at the bottom or minimum, and it should uh, stay for a long time. That means it reached for to the lowest minimum. It cannot bring further low. Okay, so that is
Sir, is
yeah.
we have to install Grace or is it
Yes, sir. Grace.
pre-installed available when we,
You have to install
or
Grace, sir. It is
separately we have to install?
yeah. You give Grace, and then in command we have to use XM. Then only it will show. Okay, I think uh, today we'll stop at here. Okay. If you may try, and if you have any questions, you can ask. I'll try to answer as I like.
I think the participants can interact with Dr. Christian Bharati and clear your doubts so that you can continue it tomorrow.
Actually, this is Ubuntu based or Linux based means we need to write command means apart from that any window based molecular simulation software is there.
What? I don't know.
Any Windows based molecular dynamic simulation softwares are there. Means I'm looking for an GUI graphical user interface like means Autodoc or other thing. I'm just asking means I know means molecular dynamic simulation is something dry compared to docking. So
You see,
make it
maybe
easy. Any other softwares are there?
Schrodinger shoot is best for that. I think this one
Yeah, Desmond
is
is,
like that. Yeah,
but that is an paid one, no?
paid one. Yeah, I don't know any Windows based MD simulation software. I think all are Linux based softwares.
Okay.
Dr. Bharati, some question is there. Can you
Windows version is
please
not there.
give step by step manual? So it will be helpful like that. Some question is there.
Yeah, I can give all the commands. Okay, and more than that, what do you want? We need initial structure files or all the MD input files and commands. Both are okay, and software must be there. And if all these things are there, we can do it. The each and everyone's level is different. So if you ask your doubt, no, that will be okay. I can exactly know what you want.
Sir, this is Baby Karpagam again. Sir, I asked the question. I have all the files that you send in my Windows download. It's in the same system. It is in Windows, not in Linux. How to bring it to Linux, sir? Because when I typed your all the comment, it says like invalid command line option, error in user input.
You have both the OS in same system or
Yes,
different?
yes, yes.
Okay, maybe you. I don't know exactly. Which
Actually, there is command, sir. Actually,
configuration can
to
you have?
bring it in Linux, I hope.
I didn't use the like that. I use different OS, means no complete Linux platform I use,
Uh,
and
Same thing, sir.
complete
I am also
Windows
using
platform.
dual operating systems.
So
So I think we have to find some files that you had sent. All these files should be put in the same folder in which our Ubuntu WSL is installed. So then I think Ubuntu will be able to parse those files when we execute it. So it's just a matter of finding the path of these files, where these files are with respect to WSL subsystem,
so
the next
yeah, some share
Windows
option
subsystem
will be
Linux.
there
I think
from
I am not able to figure that
this
out.
location.
Uh,
okay, sir. Can you tell me how to create that folder, sir, so that Linux could read that folder?
Maybe I'll, but I don't know right now.
Okay.
I represent that you.
I think someone else had else had sent a message regarding like how to install workstation work substation Linux dual
Hmm.
systems. So he might be able to answer.
Mm-hmm.
Okay, one more question is there. What is force field? should apply for simulating metal atoms with a protein structure. The same force field is okay. Okay with protein metal complexes. Okay, we no need some other force field for this purpose. And GROMACS force field is okay because no each and every simulation box contains metals, but uh, existing metals are there. Some new metal ions are there. So some uh, metal ions for force field are information won't be there in the software. At that time, we have to we face some difficulties. Sodium chlorine atoms are common. Mm, if some other heavy atoms are there, then we may face some difficulties because I faced those kind of issues. If you are processing new or rare metal ions.
One more question is there, Bharati. I think as Dr. Tanveen Kaur asked, can we provide a step-by-step basic things about this MD simulation, basic flow chart? So it will be helpful for the people who are not much into this.
Yes, sir. Maybe I will consider and I can
Yes, yes, yes,
provide some
yes,
something for that. Yeah. Okay, simulate metal ions in labs. Instead of, yeah, you can use any software for that. So lamp is also best one. Actually, Amber force field formula is very different. I showed general formula. The force field formula for uh, each and every force field is very different. I mean, they add different terms for that, and some correction terms are there. So, if you are uh, if you go through that force field in detail, we may get those information. Otherwise, they won't provide. Means Amber may provide, but Cham won't provide their force field formula uh, uh, generally. Okay, so it is commercial force field, so they won't reveal it. And no, Amber, no, it is free, I think. So its force field formula can be there.
Shall we wind up today's session? Tomorrow at the same time we can continue. Any more question?
Yeah. So I think you can copy the files. Somebody asked the question like copying files into the Ubuntu. So you have to go into the Ubuntu folder, and within that your name will be there. You have to go into that folder and copy those files into that folder. And then if you run it the Ubuntu this thing GROMACS, it will take up all those files. I just checked.
Sir, the problem is not with GROMACS. Actually, to bring it to Linux, so that Linux in GROMACS will read it.
Yeah, yeah,
I
yeah.
have this. I
Bring it to
have this
next. See,
WSL.
you,
I have this downloaded, but I want to bring it
correct, correct.
into.
So
Yeah, I
what
have
you do
them.
is,
Uh, okay,
uh, I've written this in the chat box. You can also read that. So you
okay,
have to
okay.
search for backslash WSL dollar. So if you
Yes.
type that in the search window, it will
Okay,
directly take you to that folder, Ubuntu folder. Go
okay. In
inside
the
that. Your
okay,
name folder will be there.
okay.
Go inside that and copy all the files there. So automatically, if you execute Ubuntu, it will take all those files.
Okay, okay. Sir, one more question. Can you teach how to calculate force field using Amber tools, sir?
So I'll try to look at it. Okay. If I get
Okay,
that formula, I'll explain.
okay, sir. That would be helpful. Thank you.
Let us wind up today's session. Is it? Any more questions? Thank you. Thank you everyone. Tomorrow the same time please join. I will be circulating the recordings today itself. So you can just go through that, and tomorrow at the same time we will continue. So some questions are coming. Dr. Bharati, in the simulation for molecular in lipid bilayer.
Now I included only protein MD simulation. Okay. Repeat bilayer simulation is different. Okay, you try. I'll try to. I'll guide you for that. Okay. You message me in the group, WhatsApp group. Okay. Or personally, I can guide you.
Okay. Thank you. Thank you everyone.
Thank
Thank you.
you.